You're watching Weathering Winter, a Your Weather Authority special.
Welcome back. When we talk about snowstorms that could hit our area, it's important to know about the different types of storms. Some storms have a higher percentage of being correct and others are less predictable. If you know which type of storm pattern we're dealing with, we can better forecast the storm's impact. A Miller A-type storm develops in the southeast U.S. and consists of one well-developed low-pressure system. These storms usually travel close to the East Coast or several hundred miles offshore. Often these storms pass too far to our east, and we normally miss out on the bigger snows.
Over the past decade, I'd say on average, we tend to get maybe one major snowstorm per year. I can think of a couple significant ones that have occurred in the last 5 years, for example. Obviously, some years can be busier than others, but there tends to be about one significant storm. We're talking like a foot of snow somewhere in our county warning area that occurs.
A Miller B-type storm is made up of two storm centers and is called a complex low pressure. These storms can move up the Ohio Valley and into western Pennsylvania.
But a lot of times we sort of get these storms coming off the Rockies. It'll be a low coming across that produces generally, again, as I said earlier, that thump of snow at onset, may transition to a winter mix and then sort of slam through as the cold front behind it with a little bit of back-end snow.
This setup is very difficult to predict because there's typically a high pressure to the north, which blocks the storm's progression, and its energy is transferred to a developing low along the mid-Atlantic coast. All these factors make it difficult to predict rain and snow, but Miller B storms can bring us some of our heavier snows.
Now, as far as the direction that storms occur, we're always going to get sort of these clipper systems that come through the lake effect snow in the wake of a cold front.
An Alberta clipper forms in western Canada and deepens as it tracks through the Midwest. The tracks are often near Pennsylvania before they head off the East Coast. These storms are energetic and known for their strong winds, but the Appalachian Mountains acts as a buffer, breaking up the bands of snow so very little falls across central PA. But occasionally a clipper maintains its strength and produces a narrow swath of 6 or more inches of snow, followed by very cold Arctic air. An overrunning event is when there's cold air locked into the surface and warm, moist Gulf of Mexico air is lifted over it. These are usually not big events, but can sometimes surprise us with heavy, wet snows. Winds are usually light, and the snowflakes can be big.
Speaking of snowstorms, in order to measure how much snow we get, it's important to use an accurate method, but all you need is a ruler and a board. A snowboard gives us a flat base. This can be anything from a piece of wood, painted white, or even a white cutting board. Just make sure it's a light color so it reflects any sunshine that could melt the snow. Then pick a spot to place your board ahead of the snowfall, away from houses, buildings, trees, or anything that could block the snow. And take measurements throughout the snowstorm to get the most accurate results. Aaron Tyberski, the observation program leader at the National Weather Service, shows us how.
We recommend about every 6 hours. Because as snow falls, it has weight on itself as it falls. So we don't want to wipe it off every 30 minutes or an hour, because then we'll get an unrealistic measurement of really what's on the ground.
And it's a good idea to mark the spot in your yard with something like a flag so you'll be able to find it after it's covered by the snow.
Yeah, Caitlin, those are some great tips. Bringing things back inside the studio to talk about how we get that snow to fall and then we properly measure it. We have to talk about SLR, snow liquid ratio, how much water is available in the atmosphere to precipitate and form our snowfall. Well, for 1 inch of liquid equivalent, we get about 10 inches. That's our standard metric, at least whenever it comes into our snow liquid ratio. What happens if we have more or a higher snow liquid ratio? This is a more dry snow, but one thing that hasn't changed, it's how much water is available. If this number alters in the greater side or it gets lower, well, that's going to significantly impact how much snow is able to fall. We also have to factor in not only the liquid water, we have to factor in the temperature that's above our heads, or the entire column of air. If it's cold enough or below freezing for the entire column of air, life is easy. We only have to forecast and worry about snow. Whenever Mother Nature wants to get a little stubborn, she'll throw in some warmer weather or some warmer air trapped just above our heads, and that's going to alter our precipitation type. And that drastically impacts our snow totals or projections of what we're expecting to see. And we have to factor in all of those variables plus others whenever it comes into the winter type forecasting.